In mathematics, a parametric equation defines a group of quantities as functions of one or more independent variables that are called parameters. Parametric equations are commonly used to express the coordinates of the points that make up a geometric object, such as a curve or surface, in which case the equations are collectively called a parametric representation or parametrization of this object. For example, consider the equations x plus cosine t, okay, and y, x is equal to cosine t, y is equal to sine t. These equations form a parametric representation of the unit circle. Unit circle. Okay? A point xy is on the unit circle, if and only if there is a value of t, there is a value of t such that these two equations generate that point. Sometimes the parametric equations for the individual scalar output variables are combined into a single parametric equation in vectors. That is, xy is equal to cosine t sine t, cosine t sine t. Okay? And parametric representations, of course, are generally non-unique. So let's look at this table. For the ellipse formula, we have these parametric representations. Okay? If you have a circle, x plus y square equals r square, then you have these parametric representations. If you have counterclockwise, then you have this one. If you have clockwise rotation, then you have this one. Okay? If you have in this part, if you have a curve, sorry, let me clear this part. If you have a curve y equals f of x, then you have this parametric representation. Okay, this parametric representation. Okay, let me now give an example to be clear. Okay, so the example is that the famous parabola. Now consider the famous parabola y equals x squared. Okay, this can be parameterized by using a free parameter t. So how do I do this? Let's say x is equal to t, then in this case y is equal to t squared instead of x squared. And t, what about the interval of t? From minus infinity to infinity. Okay? So let's consider the unit circle again, x squared plus y squared is equal to 1. This equation can be parameterized as follows: xy is equal to cosine t sine t, and the interval of sine, the important part is the interval of sine, the interval of t is in between 0 and 2 pi. Okay? And you can parameterize any curve, any ellipse, any circle, any line segment. It's possible to parameterize everything. And the parameterization is especially useful for us when we solve the line integral problems.